example, but it does give me an idea what equation acted by a vertical line on each side of the quantity, the graph of modulus function. Now y equals to mod x, but remember this, you'll be getting this line by using y equals 2x plus 3, getting one point, and that is again not a perfect point, right? X plus 5 equals minus x plus 4. Welcome everyone, welcome to today's class. In this class we are going to continue with our chapter equations, inequalities and graphs. So let's start, but before we do start with the class, please do not forget to like, share and subscribe to our channel. So let's begin. And the first topic is solving modulus inequalities. If you remember, in the previous class we solved modulus functions, right? Graphs of modulus functions. So let's start with modulus inequalities. Now there's a note, let's read it out. An open circle at the end of a line shows that the endpoints are excluded. A solid circle at the end of a line shows that the endpoint is included. So basically what they want to tell you is open circle, meaning this. A solid circle meaning this. That is the difference, right? There is one more way to represent this, that is using brackets. Now there are three types of brackets. I want you to know, I don't care whether you will be using it in this class or not, but you should know. Now the types of brackets are known as round brackets, also known as open brackets, right? Second is correct, this is known as square brackets, also called as closed brackets, right? The third one is curly brackets. There is no other name for this, just curly brackets, used for particular solutions. Now like I won't be going too much deep, but I'll be giving you a brief idea. Basically this round brackets or open brackets are used whenever I'll have this condition, open circle, open circle, open brackets, right? So basically if let's say my x values ranges from 2 to 6, right, but 2 and 6 are not included in my answer, I'll be using curly brackets. Whenever the extreme values are not included in my answer, I use not curly, sorry, round brackets or open brackets. But when the extreme values are included in my answer, something like this, if I have to write this in bracket notation, I'll write 2 comma 6 with closed brackets or square brackets, right? But let's say I want to write some particular values. Okay, whenever you write 2 to 6, right, what you want to say is every number or every real number from 2 to 6 is going to be included in my answer, right? And that is going to be like millions and basically infinite values, right? So we cannot write those values in the answer, so that's why we use these brackets. But let's say my answer was this only, but the question says that the value of x is only an integer. So I can say that my answer is going to be 2, 3, 4, 5, 6, some particular values. So whenever you have to write some particular values, I'll be writing them like this: 2, 3, 4, 5, 6. This is also a set notation, right? So whenever you're writing particular values, you have to use curly brackets. Whenever you have to write an interval but the extreme values are not included, you use the open brackets or the round brackets. But whenever you have to write an interval in which the extreme values are included, you use square brackets or close brackets. All right, now please note it down and please write this down along with the condition. Okay, write this as the condition. All right, please note it down. Let's move on. Algebraically solve the inequality. So the question already told me we have to solve this algebraically. So I can solve this graphically. Let me remind you, I can solve this graphically, but since the question says algebraically, let's focus on algebraically. Now we are going to exactly do the same thing that we did while solving that. So basically x minus 3 is greater than 2 and minus of x minus 3 is greater than, right? Now when we did this equation thing, what we did, we sent this negative sign to the constant one. But whenever we are dealing with inequalities and you multiply or you transfer the negative 2 sign, what you do is you change the sign of the inequality as well. So x minus 3 is less than minus 2, right? I have shifted this negative sign with 2, but I have also changed this sign of inequality to from greater than to less than. Now you can solve this like a normal way. Let's shift it there. I'll get x is greater than 3 plus 2. So x is greater than 5. And if I'll shift it there, I'll get x is less than 3 minus 2. X is less than 1. So my answer comes out to be this only, x is less than 1 or x is greater than 5, right? You can write here also x is less than 1 or x is greater than. All right, please note it down. All right, next, if you need more time, please pause the video and note down the solution. Next one, solve the inequality, and now we have a graphical method, and obviously since we have two modulus signs, need graphical way. All right, now again we'll be solving, we'll be drawing the graphs like a normal way. That is, first let's draw the graph of 3x plus. So before that, let's write the numbers 1, 2, 5, 0, minus 1, minus 2, minus 3, minus 4, minus 5, 1, 2, 3, 5, and the exact same way this one also. All right, 3x plus 2. So if you want to draw the proper graph, just draw the table x and y. So not 3, we need only 2. So when x is 0, y is 2. When x is 1, y is 5. So when x is 0, y is 2. When x is 1, y is 5, right? So let's draw the shape. All right, now when we'll reflect this, get something like this. Okay, now let's do the same thing for the other one as well. That is 2x minus. When x is 0, y is minus 3. Okay, we can't have negative y values, so let's use some other value. So when x is, let's say, 2, y is 1, when x is 3, y is 3. So let's draw the graph. Okay, why didn't I take the negative value? Because if I'll take the negative value, this graph will go below the x-axis, and that's not what I want when I'm dealing with modulus functions, right? So when x is 2, y is 1, x is 2, y is 1, x is 3, y is 3. So when I'll draw the graph, I'll get something like this and this, right? Now, okay, wait. Let's choose a different color just for proper representation. Okay, so something like this, right? Now again, I told you that I need to have two solutions, but I'm only getting one. So let's figure out which will be the other solution. It's very much clear that we have one solution, that is this point, right? And when this blue line is like extending, it's moving closer and closer to this yellow line, right? So there will be a point where these two lines are going to intersect, right? Okay, so let's find out those 2 points first. Let's find out this point, that is what is the equation of this line? This is 3x plus 2. What is the equation of this line? Minus of x plus 2, correct? All right, now this line is minus of 2x minus 3, and this one is 2x minus 3. All right, okay. Now when minus of 2x minus 3 will be intersecting with 3x plus 2, what will happen? Minus 2x plus 3 equals 3x plus 2. If I shift it there and I'll shift it here, I'll get 5x equals to 1. So x equals 1 over 5. So the x coordinate is 0.2. Correct? And now similarly, let's solve for this one. So I'm solving it here, okay? Minus of 3x plus 2 equals to minus of 2x minus 3. Let's cancel the negatives. So I'll get 3x plus 2 equals 2x minus 3. I'll shift it there and I'll shift it here. I'll get x equals to negative 5, right? Now these two graphs will intersect at x equals to negative 5. Now what does it say? That the graph of 3x plus 2, what was the graph of 3x plus 2? The yellow one, right? So I can see that the yellow graph should be below the blue graph. That's what this means, right? This is the equation of the yellow graph. Less than or equals to, then blue graph. So yellow graph is less than the blue graph, correct? Now in which area the yellow graph is below the blue graph? Now check this region, this region. In this entire region till the point where they'll meet, right? The value, the y coordinate of the yellow one is always less than the blue one, right? And that's what I want. The yellow graph is less than the blue graph. So, and where they'll meet? At minus 5. So somewhere here, let's say, right? So I can say that at this entire region where from minus 5 to this point, the yellow graph is below the blue graph. So I'll say that from minus 5 is less than equals to x is less than equals to 1 over 5 or 0.2, this answer is going to satisfy. If you don't agree with me, just check. All right. Another way what you can do is, now you have three regions from the 2 points of intersection, right? From the 2 points of intersection, you will get three regions. One like on the left side of this point, one in between these 2 points, and one to the right of this point, right? Pick any x value, okay, and substitute that x value in these two answers, like in these two equations. You'll get some values of y. Just check if this value is less than this or not, right? For just an example, let's put x as 0. I'm getting x as 0 in between this one, right? So let's put x as 0. I'll get what? Modulus of 2 here, and what I'll get here? Modulus of minus 3, correct? So modulus of 2 is 2 and modulus of minus 3 is 3. So 2 is obviously less than equals to 3. So that is going satisfying my equation. So that's why this region is my answer. All right. You have two ways. First one is drawing the graph and then finding the answer. And then you can check it or cross check it using this method by dividing into three regions and then putting any one value of all the three regions in your equations. And if it's a correct region, it will satisfy the condition. If it's not, it won't, right? But make sure that the graphs are correct. All right, please note it down. All right, let's move ahead. If you need more time, pause the video. Next one, using substitutions. This is a very easy topic and like actually saying not very important, but still we are going to study it. Basically, whenever you will be having an equation in which you have a variable and a square root also, basically you will be having a linear equation, but there will be a square root. So we'll consider that equation to be a quadratic. Now how? Let's say your equation is x plus 2 root x plus 3 equals to 0. Now you need to solve this equation. Just an example, please don't stress too much about this. All right, just an example. So there is no way we can solve this equation. So what I'll do is I'll put x is equals to u square. Now what that will do is root x will be converted to u. Now you can see that I have an equation which is a proper quadratic equation. Now I'll solve this equation. I'll find the values of u and I'll substitute this value of u in this equation to find the two different values of. All right, everyone. So let's move on to a question related to this. Solve x square minus 3 root x equals minus 2. So first let's write this in the standard form, that is x minus 3 root x plus 2 equals to 0. Right, everyone? Okay. Now what we are going to do is we are going to substitute x as u square. So if I'll substitute x equals u square, what will I get? U square minus 3u plus 2 equals to 0, right? Okay. So let's use splitting the middle term. U square minus 2u minus u plus 2 equals to 0. U minus 2 minus 1, u minus 2, 0, u minus 2 and u minus 1 equals to 0. So u equals to 2 or u equals to 1. Now let's substitute these values in here. So I'll get x equals 2 squared, that is x equals to 4, and I'll get x equals 1 squared, that is 1. So these are my two values of x that will satisfy my equation. If you don't trust me, please check it. All right, substitute these values of x as 4 and 1 and you will be getting the answer as -2. All right, please note it down. Okay, before we move on, I'm going to give you one random equation. It might give you a perfect answer, it might not, but hold on. Just give me a few seconds to just think. Try this equation, okay? I'm not sure, but fine, we can try. All right, okay. Let's move on to the next one, that is cubic graphs. Now, you might see some random drawings here. They are actually not random. Basically, this is the standard form of a cubic equation. We are talking about equation. Let's put equals to 0. If not, this is the standard form of a cubic expression. All right. Now, what happens is this coefficient of x cube, that is a, defines the shape of the graph. All right. Always the highest, the term with the highest power, the coefficient of that defines the shape of the graph always. In case of quadratics, the value of a used to decide whether my graph is like opening upwards or opening downwards, right? The same thing happens with cubic graphs also. The value of a decides what kind of graph it's going to be. Now, when a is greater than 0, meaning this x cube term is a positive, you get a graph something like this. So if I'll draw this graph here, you should get something like this, right? Now, when we're talking about, hold on, yeah, when we're talking about a less than 0, right, my graph should be something like, all right. So that is the like a basic difference between the graphs and how they depend on the value of a. All right, if you want to, please note it down. There's nothing else, just the important thing is the shape of the graphs at certain values of a. All right, please note it down. All right, let's move on. Using graphs to solve cubic inequalities. So basically, we are not going to study this for now. Yeah, let's study this. First, we are going to draw the graph of this one. All right, in the next one, we are going to deal with the inequality. So, we have sketch the graph of y equals 3 times modulus of x plus 2, x minus 1 and x minus 4. Now, even just forget about the modulus thing for now, right? Okay, just erase it from your memory. Just erase it from your memory. Okay, let's just erase it for from our memory. Now, we still have to draw the graph, right? Okay. Now, since the graph is already given in linear factors, it like actually relaxes me a lot, right? So, these linear factors gives me the roots. So, one of the root is going to be, let's first name it down, -1, -2, -3, -4, -5, 1, 2, 3, 5, -1, -2, -3, -4 and -5 on 0. Okay, hold on. Let's use some bigger values. 6, 12, 18, 24, 30, minus 6, minus 12, minus 18, minus 24 and minus 30. Right now, one of the values as x as minus 2, that is this one. The other one is x as 1, that is this one. The last one is x as 4, that is this one. Right, even when we didn't have a modulus sign and I'll multiply the x with the x with the x, I am going to get a positive term, right? So it's very obvious from the previous slide, not this one, that this should be my shape of the graph. Right, now my graph should look something like this, right? But not exactly. Now why not? Because we don't know where this graph is going to intersect the y-axis. Now let's try that. So when I'll put x as 0, because on the y-axis x is 0, so I'll get 3 times 0 plus 2, that is 2, 0 minus 1, that is minus 1, 0 minus 4, that is minus 4. So minus minus cancel, 4 times 2 8, 8 times 3 is 24. So my graph should intersect the y-axis at this point. So my graph should look something like this, right? Again, not a perfect graph, but at least you drew two things, important things perfectly. Now what are those two important things? The first one is the intersection of the graph at the x-axis and the y-axis. That's the first important thing. The second one is the shape of the graph, whether it was like starting from lower value or the upper one. So these are the only two important things when you draw a graph. If you miss these values slightly, it's completely okay. All right, so please note it down. All right, okay, did we miss something? Yes, obviously we did. So I told you in the starting of the question that erase it from your mind that we have a modulus, but we didn't have to completely erase it, right? We need to solve it. Now since this is a modulus graph, what we are going to do is we are going to remove this part from below the x-axis to above the x-axis, and it should be something like this. And similarly, this graph also, that was below the x-axis to above the x-axis, right? Okay, now you can copy it down and let's move on to the last topic and the last question. And the question is, solve the inequality 3 times x plus 2, x minus 1 and x minus 4 is less than equals to minus 100 graphically. All right, now when we drew the graph of this, see, again I'm not going to draw the perfect graph, but I'm going to give you an idea on how the question needs to be done. Let's take some bigger values: 20, 40, 60, 80 and 100. Correct? Minus 20, minus 40. Okay, let's take even bigger values just to make you understand. I need some bigger values. So let's take 40, 80, 100, 120 and minus 40, minus 80, minus 120, minus 160 and so on. Now when you draw the graph passed at 24, that is somewhere here, right? So the graph should be something like this, but when it will go like below the x-axis on, and it will be something like this, right? I'm again saying it's not the exact graph, but yeah, it will be something like this. So it should be less than -100. Now where is the line -100? It will be somewhere here. Yeah, right. So this graph should be less than -100. So that is very much obvious that the question is asking me to find this region, right? Now all I need to do is find the intersection of this point and this point, and that will be my answer. And that can be done if we are going to draw the exact table for this graph and find the exact graph. All right, so that's how we are going to solve this equation. And if we are going to draw the exact graph, might be you will be able to find the x coordinates like that, right? All right, so if I have to just shade, if the question was shade the area, this green part would have been my shaded area. All right, okay, so please note it down. All right everyone, so that's it for this class. I hope everything is cleared, and with this we are at the end of this chapter. So we'll be meeting in our next class with another chapter. Till then, please practice some questions. And although you have a book, right, I know every school has a book, but please try to solve previous year question papers as well, as much as you can. All right, so with this, let's take cut. All right everyone, so that's the end of this class, and with this class we have completed the chapter equations, inequalities and graphs. I hope every topic is crystal clear. So let's meet on in our next class with another video. Till then, practice questions and take care. Thank you. If you had a blast watching, give us a thumbs up, share it with your friends and subscribe our channel to stay updated on all our future videos.